Hello, this is going to be a tutorial on how to do nuclei counts for the Bastion lab. This is particularly a tutorial for Luke's nuclei imaging. They're sort of whole well images. I'll display them and show you. But this is how you can do it. So if you had the bundled app, you could open the bundled app. If we've done it from command prompt with UV, you could type in something like UVX napari-ndev. That'll open it. I'm going to do it from VS Code just because I want to show some other things in there. So in VS Code, I'm going to type in UV run napari-ndev. And that is in this project here. I have initialized a project repository, so it'll have a pyproject.toml file. And I then add napari-ndev all with this upgrade thing so that you have the most recent version. This is recent as of version 0.11.0, which I released in February 2025, with some fun features, but it's going to be changing a lot as I work on the manuscript. So here's what opened up. We have the napari-ndev app loaded. If you load it from the bundled launcher, you're going to have to go into plugins, ndev app, and you can install it from up here. If you install it from up here, you're going to have a little bit of funky issues with trying to load CZI files. But where we're at starting on Luke's experiment is I have currently the extracted scenes because we did this from the lab, and I only uploaded these to GitHub because they fit, and big files don't fit on GitHub. So, but for the tutorial, I put these over here. But how did I make those extracted scenes? That's kind of important. So we're just going to do it for a different thing. Tonight I have to do some work for Daniel. So I'm going to come into the nuclei counts. I just have as raw image, right? This 3.7 gigabyte image that I downloaded off Google Drive. It's the raw CZI file. And when we do this, it's going to propagate some metadata for us. It's going to tell us that, for example, that there are 20 scenes. Here's sort of the image sizes. We've got two channels, oblique and hoaxed. We've got our scale here. And what I'm going to do to kind of like make them compatible is I'm going to do extract and save scenes. Because I don't have any information in here, it's just going to do all of the scenes, and it's going to kind of propagate this metadata onto it. So when I do that, we're just going to have to wait a moment as it's going to be spitting out all these scenes. Soon this will be multi-threaded so that there won't be this like if we click right now, it's going to look like Napari is broken. You just have to wait a moment. But soon it'll be multi-threaded, and it'll kind of smoothly run and sort of update as we go. We're just going to wait a moment. Hopefully not too long, but we could probably check in our folder. So here is his folder, and we've got an extracted scenes folder, and then we can see that it's now adding those images, and there it says saved to the extracted scenes. So let's say you only wanted to do certain scenes, right? You could say I want scene 1, 5, 12 or something like that. You could just do that. Or we could open the file, and then we're going to have a little widget open here, and we can just sort of select which image we want to look at, and this is sort of an example of what we're looking at here. So here's our oblique. We can rechange this to gray, and then this one we'll change this to cyan just because that's what it might look like on your screen. So here's our oblique, right? We've got neurons. These are 7 div neurons. And then here's all of our nuclei, right? They're not super prominent, but I'll show you kind of how we're going to manage those. But for now, we don't need those. So what do we need in order to do this project? Well, in here already, as I mentioned in this sort of tutorial here for Luke nuclei, we just have our extracted scenes. And in Luke nuclei, I've made previously, and this is kind of the advantage, is a shareable file, this .yaml file, and we're going to take this .yaml file and stick it in here. We don't have to. We could access it from there, but just to kind of put it all in the same spot to say this is what we used. I made this file by using the Napari assistant here with those images open, and I took processing steps. What those processing steps look like very simply in this segmentation file is that we take, for example here, we take the DAPI image, we run a median sphere, and we output what's called the median image. We take that median image, we do a top hat with these different parameters, and then finally we do this Voronoi Otsu labeling to get the nuclei labels function. So that's great. So what does it really look like to run in here? Well, we can go to the workflow widget, and we can select that file. You know, I could select the one in here, it doesn't matter. And that's going to propagate here and say, well, we have one root that we need, and we don't have anything in here. So if we had, we could actually even, why don't we try this with one of Daniel's? So we're going to try to open his file again, and we're just going to pick any of them. And it's going to say, now it's going to inf in this list, right? We could do oblique or H3342. This is the nuclei channel equivalent to DAPI. We could do this. We could say viewer workflow, and it's going to attempt to do the same thing. Now, this isn't tuned for Daniel's. It actually looks like it did a great job. We can convert this to labels, and there we have it. We have the labels for this image from this workflow file, which honestly looks really good. I'm pleased. So this is kind of the idea behind the shareability behind this. So that's we can interact with it from the viewer, but we actually want to do Luke's project. So in order to do that, we're going to go to image directory, tutorial, and I'm just going to pick the folder with all the extracted scenes. Now in here is going to be the channels that are in those images, and we're going to make a results directory for this. So I'm just going to make this called tutorial output. I'm going to select this folder. I'm not going to keep the original images, and this is going to run through everything. Now we could pick which tasks do we want, but it's just going to take the one that's at the root or the end, the terminal end of the tree or the leaf. But you could pick all the other ones if you wanted. And we're just going to hit batch workflow, and this is where we have threading hooked up. So now if I can interact with Napari if I want to, while this is running the workflow on Luke's 21 images. Okay, so we're all done. Now, if we come into here, let's say we wanted to, we could just drag an image on. We're just going to drag the second one on as an example, and then we can go to tutorial output to kind of like see, hey, does that look good? It's going to look a little different at first. And interestingly, one of the things we can see here, I think right away, is that the nuclei got reconstructed a little bit smaller, but I guess they generally are smaller. So when we compare that to the oblique, right, they're a small portion of it, but that makes sense. And yeah, there we go. So we can presume that's going to be, it's going to look good for all of the files, right? We could see how Daniel's and Luke's are very different sizes, but they work pretty equivalently. Right, we could change this to green, so then it looks like almost exactly like Daniel's, and then we could turn those off and we could see Daniel's underneath. Okay. So then from there, really we only have one more step for Luke to do. This is sort of the most complicated one, so I'm going to kind of walk through what the plan is first before showing how to do it. So in here, what we want to do is like we've got a name. This is like the name of one of Luke's files. It's got, you know, the date, how many days in vitro it is, what's sort of the plate is, when it was imaged here, and then because it's extracted, you've got what scene it is and what well position it is. So from this, we can create this dictionary that we're going to use in the napari-ndev app, where we can extract the well data, where we're saying, okay, if there's 2 underscores and then this A to Z in digits, we collect the well. We get the scene from this information here. We get the start date, which is at the beginning. We get the imaging date, which is here. We get how many days in vitro by extracting with these different regex profiles. So if I do that, right, I can just import this function from napari-ndev measure, and there we go. We've got it extracted from this string, right? We run this function and it gives us our information. The other thing that we have for Luke's experiment, and like Luke, this is what you would need to modify depending on which plate you're using, but you have like where your treatments are and then what wells they're in. And if you put it in this way, it's like on a rectangular shape when we run this function, which you don't have to do, but this is just visualizing it in the notebook so that we understand, right? We see that, okay, so I put in A1 through B3 is control, A4 through B6 is 4 micromolar DFO, and right, we can do that for all of our treatments. We can do that the same for whether or not we add the mimetic SOB AM2, and there's kind of our plate maps. So from there, the last step for our measurement is we come back to napari-ndev, and in the measure widget, we're going to choose where our labels are, which in here is going to be in tutorial output. And now that's going to load this in. So the labels that we want to measure are the labels, nuclei labels. We don't need to measure any sort of image. Oh, there's one more thing that we needed to do. So in previously, we had added a region of interest here of where we want to measure. It's just sort of in the middle of the well. Oh, this isn't scaled properly to this image. Let me pick the one for the image itself. We'll grab the second one. This should be in a slightly better position. And so we just try to pick somewhere in the middle of the well that isn't going to hit any of these posts. Oh yeah, right, because here's our image. So we could just turn these off. Okay, so there's our image. We're going to turn this to gray. And then we basically want to measure anything inside this circle, which the circle was safely placed so that we're kind of ignoring the post, but also for a seahorse plate, right, this is kind of, in a sense, the area that's kind of being measured. Maybe, I don't know, there's gas exchange, or, media exchange. But anyways, so in order to do this, we create this labels layer, but we can really do it with a shape. Here's how we actually did it. We do a shape, and then we draw on our shape. This is right. Okay, so this is we're fixing this in napari right now. The first time you initialize a labels layer, it'll be kind of slow. And then there's a way, one of the buttons you hold to make a perfect circle. There we go. So there's our circle. We could put it there. Wow, that was pretty close in size. I'm impressed. And then we're highlighted on this layer, and we could do, so we would have here, for example, we're going to do this in the tutorial. We're going to just grab the first image. I'm going to open this file. It's not going to open that interface. There it is. So it's just basically going to match that file. We don't need any other information because every time we hit select next, it'll repropagate this. But we can do export selected layers as TIFF. So it's going to save the shapes label into, well, the first time we ever select it, it'll always put it in the correct folder. But this time we have to select our specific, where our tutorial folder is, and we do select layers. Selected layers. And now it saved it. So if we come in here, into the tutorial one, we now have a shapes thing with one image in it. This is the, where that shape is. And then we could just do select next, save selected layers, and it's just basically going to put this onto each of the images. But instead of doing that right now, I'm just going to grab the ones that I have in here. Oops, not control. I want to just control copy. All right. I'm just going to replace the files that I made, and there we are. Now they're the correct size. They were, unfortunately, the incorrect size because that means that Daniel had effectively 2x the resolution, because I was actually using Daniel's, so you wouldn't want to have it filled up with all of this. You'd want to make sure it was the proper size. So it's going to base it on the bottommost thing, because the shape is sort of existing in vector space, not raster space. But that's here nor there, sort of. All right, so in the measure widget. Alrighty, so we have our labels selected. We want to also select our region, which is our shapes folder, because this is our region of interest. And so we want to do this against the region of interest or shapes layer. And then from here, we're just going to measure label and area. Area is going to kind of give us a bit of a quality control measure, because if we take the mean of areas and something wasn't right for an image, it would look a bit wrong. We could measure intensities if we wanted, if we put an image in here and we could say more intensity images. Oh, we do need to measure the intensity maximum. This is the most quirky part that I haven't figured out maybe a more intuitive approach. which is where we want to measure the intensity of that region. So this region will have a value of 1, and then outside of it will have a value of 0. So any nuclei label that has an intensity maximum of 1 is within the region of interest. So that's that. Then for our ID regex, we have this. So for you just have to copy and paste it from this folder, as long as your file names are saved similarly. For our treatment map, we're going to come here, we're going to say update, because right now we've just got update treatment ID choices. We're going to update it. So now it includes well, which is sort of where we know our treatments are is based on what well it is. And I'm going to say I have a 96 well plate so that when I map this on, it knows what size plate. So you could do, you know, like for example, seahorse plates, you could do a 24 well plate and have a map for that, or a 6 well plate or whatever. Okay. So we want to select an output directory here. So I'm just going to output this into the tutorial. It's just going to save the data right into there. You could make a data directory if you wanted. We're just going to hit measure. And then here we go. And it's chugging along, measuring all our images. And there we go. So that quickly. We come in here, and now we have this large-ish file. Wow! Which has 1 row for every single label, and you can see they're slowly changing as we scroll through. And this ultimately has, you know, 12,000 rows. Not very useful. So we're going to come back here. We're going to go to the grouping tab. We're going to grab that data. Make sure we close it. If we have something open in Excel, basically Excel prevents you from writing to the file, so we want to make sure that we always close it down if we open it up. We don't have to though. So in the tutorial, I'm going to grab our measure props nuclei. I'm going to group them by certain features. Of course, I want to group them by the label name and ID, but I also want to group them by other treatment information like image date, div, start date, what scene it is, what well it is. And then I'm going to group it by the intensity maximum of shapes, which means that if I take the mean number of cells in intensity max shapes, I'm going to get ones that are in the ROI and ones that aren't in the ROI. We're going to count the label column, and then we can aggregate if we want. Like we could take the mean, for example, of the area. And then when we do that, we're going to leave this pivot wider on because it's just going to make it look nice. And we're going to hit group measurements. It's just going to say grouping measurements. It's already done. I should update that to say grouped measurements. And then in here, we've got our nice little file. And in our file, we have, for example, in, you know, ID is like the full length name of that whole image. But we could see, right, plate 3, 18 div, it was imaged on this day, scene 0 and well 8.1. It has, inside the region of interest, a value of 1, 217 cells. Outside the region of interest, 459. If we look at the area mean of the labels, right, we could see that it's around 130, and nothing looks really weird, except for maybe we want to check this file, A2. We want to check A2 because it's got kind of a lot of cells not in the region of interest and maybe a little less than normal in with a small size. So we're just going to double check. So in order to do that, we can come back here. You could drag them in from your files. So what did we say we wanted to look at? A2. Oh, funnily enough, I think that's the one we were looking at earlier. So, yeah, A2. So we've got extracted scenes, and then we can go to our tutorial output, which also grab A2, and we'll stick it in here. We're going to need to convert that to labels. One day I'll think of a way, but to me, this doesn't look wrong. Every single cell that has a nucleus on here is labeled, and the nuclei look to be the correct size. So I'm content with this. There's a lot of variety in these images. And so there you go. That's how you run this workflow. Thanks. Good luck. Let me know if you have any questions.